Okay, welcome to our fourth session, fourth tutorial on the brightness discussion. We've addressed so far kind of the history and where brightness has come from. Then we talked specifically about the TAPPI brightness measurement and how it evolved over time, is known as the directional method, and then how in the 1950s the ISO method came along. And with that, then we have a diffuse geometry, but similar viewing, and we've viewed some names and concepts between those. So now we have an understanding of kind of brightness measurement, the two different methods we have for doing that. And we want to take a few minutes in this video and talk about what are the differences and what are the similarities between those. As we talked about previously, both technologies, both ISO and the TAPPI method, use the same filter function, knowing that we're looking at the bleaching process that we want to evaluate, and it's an excellent tool for doing that. But it is colorblind, if you will. It does not see in the green and the red region of the spectrum, the rest of the spectrum. So once you start adding significant colorants, especially as you start to saturate out in those colors, whether it's a goldenrod or it's a salmon color or even a deeper, more saturated color, the technology isn't good for that because it doesn't look in those regions of the spectrum. So really, brightness was defined to measure the bleaching process and look at white and near white papers, and both of these technologies do that well. We identify three things as an instrument manufacturer to get two instruments to agree with one another. They have to have three things in common. They have to have the same geometry, meaning that they have to illuminate and view the sample the same way. These two do not. So it's geometry, photometry, in that they have to have the same calibration. We'll talk about that in the next video. They're different with that. And the third one is spectral response. So it's geometry, photometry, spectral response. And spectral response, they have this, and so they agree on that. So 1 out of 3 is where they agree. So if they only agree a third of the time in those three parameters, then we can't expect they're going to agree with each other when they measure your product. So that is the case. If there's been one question that I've had more often than any other in my time here at Technine is, what is the correlation between TAPPI and ISO brightness? The answer is none, because it all depends upon the many different aspects that we've talked about as we've discussed these two and how light interacts with that. So we do not find that. So in this particular case, we've loaded a sample on the TAPPI instrument. Let me step around here so I can, and the value is 95.3. I'll take this same sample over and I will load it on the TB1, which is an ISO brightness instrument, and the value is 96. So just that one sample, we see about a 7/10 difference between the two instruments. I've seen as much as 2 points difference between the two on some products, and then there's other products that it's within a tenth or so. And so it really depends upon what it is you're measuring. Some of the clay products where you don't have much directionality, you can get a pretty close agreement between the two. But when it comes to paper, if you change anything in that paper, whether it's the fiber or it's the fillers you put in there, it's going to change the relationship. And so one will go higher and one will go lower. And you can't always say that TAPPI is higher or ISO is higher, because again, it depends on a lot of the different optical characteristics of that sheet, which will determine what its ultimate brightness is based on the two methods. So you just cannot, predict that number. So beyond that, one of the big differences between the two instruments is the sample opening, the area of view that you have with the instrument. On the TAPPI method, you can't see it here, but on that, you've got an 11 millimeter opening, and the area of measurement is 9 millimeters. So it's looking at a fairly targeted area in that sample. On the ISO, one of the things that they wanted to do with the ISO group when they developed this technology is they wanted to open that up because they felt like it was too tight. So with this guy, the opening is 34 millimeters, and we're measuring at 30 millimeters. So it's looking at a much larger area of the sample than what this is. So you've got a difference in this guy's kind of small, and this guy over here is kind of big in the amount of area that it's looking at. So there is a sample size difference between the two. An interesting thing that happens with the TAPPI method, with the directional method, we've not defined gloss or specular reflection at this point, and we'll do that in a future video, but let me just say real quickly, gloss is the light that goes off at the opposite angle. So in this case, if we've got light coming at 45 degrees, we're going to find gloss as the light that goes off at the opposite 45 degrees. Okay? So the more gloss you have to a sample, the more light it's going to send off this way, driving its brightness down, will level down a little bit. But that's okay, because when you are looking at a magazine, let's say, and it's got a coating to it, or it's a fairly glossy sheet, you're going to adjust that paper until you eliminate the effect of gloss, because the gloss is a surface interaction and is going to keep you from seeing it. So the TAPPI method does a very good job of excluding the effect of gloss. The ISO method does now. Originally it did not do that, but they had to make some adaptations to the sphere, and that's why there's a large opening at the top of this. There actually is a black insert that we put inside here, and what that does is that keeps any of the gloss component, which would be light that reflected off the area around the photocell here, that would go down, strike the sample, and come back up. Let's say go in at 2 degrees and come back out at the opposite 2 degrees. Well, it would get captured in that signal there and would artificially elevate the brightness readings. So the ISO group, after a couple of years of having this in the marketplace, realized that was an error. So they put this black gloss trap insert in here, and so now today we make all the ISO instruments with that gloss insert in there so that we take out as much of the effective gloss as we possibly can. But the two products, because of the geometric difference, do handle the effect of gloss differently between one to the other. So you've got the geometric difference, you've got the photometric difference, which we'll talk about in calibration. Now, where are they used? So in the United States, TAPPI still is the predominant method that's used by the paper manufacturer. You go into some of South America and you see quite a few TAPPI instruments. Travel over into Europe, you don't see many TAPPI instruments unless they're making a product that's going to be shipped back to the States. And then you'll see an instrument or two where they want to do a final verification of the data before they load it onto a ship and ship it over. In Asia, well, certainly in Japan for a period of time, they had a directional method. They've now modified that, and they're moving more towards the diffuse geometry with that. So it varies wherever you are in the world, but as a rule of thumb, you can assume that in the U.S. it's the TAPPI directional method, exceptions being the newsprint industry that globally standardized on the ISO method many years ago. Most tissue manufacturers are going to go with the ISO method because of some translucency issues there are with that this does a better job of handling than the TAPPI method does. For some reasons, those that are measuring optical brighteners and have sheets that contain OBAs in them, and we'll talk about this in another video, there's some things about the TAPPI method, the directional method, that handles that better than the ISO method does. So it is a combination of things out there. But the important thing is when you're communicating with your supplier, your customer, is that you don't just say brightness, but you define what is that brightness. Because if I just say brightness and I'm using a TAPPI instrument, but yet you've come to your values based off an ISO instrument, and I get your sample over here, I'll measure it, and I've got a wrong target because we're not talking the same language. So when you communicate brightness specs, you want to say, I did this via an ISO standard, I did this per a TAPPI or directional standard or diffuse standard. That way you've more accurately expressed what method that you're using with that. So you always want to make sure you're communicating those pieces. Another place we see that the ISO method is more frequently used is the pulp mill. And that really comes back to what we talked about early on when you have a pulp hand sheet. What is the orientation of that fiber? Well, it's random in there. And so if you're measuring on a TAPPI, you're going to get a lot of variation across that sheet because of how those fibers are interacting with the light. You come over here to the ISO instrument and you will see that basically the standard deviation in your data is going to come down quite a bit because you're averaging out a lot of that non-uniformity, non-directionality of the fibers in that sheet. So in pulp mills, you'll see a lot of the ISO geometry. Communications, and understanding what it is you have are keys to making sure that you're doing the right measurement for the right application when it comes to whether you use ISO or TAPPI. Next video, we're going to look at how we calibrate these guys and what they're calibrated to. Thanks for watching.